students. For this video, we are going to discuss random sampling and sampling distribution of the sample mean. Let's discuss first sampling techniques. In order to utilize the time of the researchers, it is important that researchers understand the right ways of selecting a sampling method for their research. It is because they are working with samples to collect data information of their respondents from a large population. Now, this illustration will show the relationship of population and sample. Population means it consists of the entire group that is the subject of the study. The process of selecting participants from the population is called sampling. After selecting participants, the group of people which are members of the population is called sample, and the data will be collected from them. But you have to remember that when it comes to selecting participants, it must be done carefully and fairly to avoid biased samples.
When we select samples, there are two divisions. 1. Random sampling, and 2. The non-random sampling. When we talk about the first division, which is the random sampling, it is a process whose members have equal chance of being selected from the population. From the word random, which means unknown or unspecified. Since we don't know who to select, everybody has the same opportunity to be chosen. Now, there are 4 random sampling methods. We have simple random sampling, systematic random sampling, stratified random sampling, and lastly, the cluster random sampling. First, the simple random sampling. It is a process of selecting sample size in the population via random numbers or through lottery. We have different methods that are involved, such as drawing strips of paper with number written or using random numbers. Second is the systematic random sampling. It is defined as a process of selecting kth element in the population until the desired number of subjects or respondents is attained. For example, in a given data, you will consider every fifth or whatever nth you prefer. Next is the stratified sampling, which is a process of subdividing the population into subgroups or strata and drawing names at random from each subgroup or stratum. To make this more understandable for you, let's have an example. We conduct a survey about timekeeping, and with that, we can divide the population by time zone, and then that will be the time for us to take 100 samples per zone. Last but not the least is the cluster sampling. It is defined as a process of selecting clusters or groups from a population which is very large or widely spread out over a wide geographical area. The keyword here is geographical. It means it is connected to large area or numbers or space. Example for this, if we want to determine the opinion of the residents in Manila regarding its improvement of living, by the use of cluster sampling, we can subdivide the city into districts. Then, select at random the numbered districts to be used as samples. Now, the second division, the non-random sampling. It is defined as a sampling procedure where samples are selected in deliberate manner with little or no attention to randomization, also called the non-probability sampling. There are 6 sampling techniques involved. Let's talk about the first technique of non-random sampling, which is the convenience sampling. It is defined as a process of selecting a group of individuals who are conveniently available for study. For example, a researcher may only include close friends and clients to be included in the sample population. For you to understand this further, in reality, it is easier to approach the ones who are close to us. That's why it's convenient. It saves time and energy since we already know them. The second technique is the purposive sampling, a process of selecting that is based from judgment to select samples from which the researcher believed. Based from judgment to select sample needs. Example, a human resource director interviews the qualified applicants in a supervisory position. Take note, qualified applicants are selected by the HR director, which is based on his own judgment. Next is the quota sampling. It is applied when an investigator survey collects information from an assigned number or quota of individuals from one several sample units fulfilling certain prescribed criteria or belonging to one stratum. Let me give you an example or situation related to this. When the respondents are composed of men over 30 or 20 people who have bought cellular phones in the last week, it is in the interview's discretion which men or cellular phone buyers they select. Fourth is snowball sampling. It is defined as a technique in which one or more members of a population are located and used to lead the researchers to other members of the population. For instance, attempting to obtain the frame that includes all homeless people in Metro Manila. So to obtain a sample of homeless individuals, for example, the researcher will interview individuals on the street or at homeless shelters. The fifth one is the voluntary sampling, a technique when samples are composed of respondents who are self-select into the study or survey. Most of the time, samples have a strong interest in the topic of the study. Let's consider a news show asking their viewers to participate in an online poll. The samples are viewers who have chosen themselves and not the survey administrator. So in other words, the participants are volunteering. Last but not the least, we have judgment sampling. When we talk about it, it is a technique when the researcher relies on his or her personal judgment in choosing to participate in the study, or the sample selected is based on the opinion of an expert. For instance, a study wherein a researcher wants to know what it takes to be a top-notcher in a bar exam. The only people who can give the researcher first-hand advice are the ones or the individuals who are bar top-notcher. About this, our decisions or source of data will be based from an expert or people who we trust and believe. Now, let's proceed to parameters and statistics. This time, we will know how to distinguish between a parameter and a statistic. When we talk about a parameter, it is defined as any quantity that describes a characteristic of a population. The keyword here is population for parameter. So allow me to give you examples of parameters. One is standard deviation of weights of all avocados in the region. Then the other one, proportion of all residents that support the death penalty. If you notice the word all, it represents population. So that's why these are considered as parameters. Next is statistics. These are any quantity that describe a characteristic of a sample. For instance, standard deviation of weights of avocados from one farm. Another one is proportion of 2,000 randomly sampled residents that support the death penalty. If you observe, these examples just represent a portion or a part of a population.
Now, let's discuss sampling distribution of the sample means. Sampling distribution is generally the probability distribution of the population data of a sample statistics. It can be applied in two ways. First is sampling with replacement, and second is sampling without replacement. When we are talking about sampling with replacement, it means that it is when the two samples are independent, which means that we are going to use the counting rules for permutations. And when we are talking about without replacement, it means that the sample values are dependent. We are going to use the counting rules for combination. These are the formulas that we are going to use to easily compute and understand the applications of sampling distribution. And these are the formulas that we are going to use for sample means for a sample size, which can be drawn without replacement from the given population. And these are the formulas that we are going to use for the sample means for a sample size, which can be drawn with replacement from the given population. Now, let's try this given example. This table shows the data consumption per day of synchronous online classes consists of 6 grade 11 students. And these are the following questions that we have to answer. For letter A, what is the population mean? population variance, and population standard deviation of the given data. B. What is the sampling distribution of the sample means given that the sample size is 2, which can be drawn without replacement in the given population. C. What is the mean, variance, and standard deviation of the sampling distribution. D. What observation can be made with respect to the population and the sampling distribution. To answer the first question, we have to solve first the population mean. Noted that the given values of x are 80, 150, 125, 100, 175, and 90, which represents the data consumptions of the students. Next, the total number of students n is equal to 6. To easily solve the population mean, let's find first the summation of x. So we'll have 80 plus 150 plus 125 plus 100 plus 175 plus 90. It is equal to 720. Now, we are going to substitute the values of the summation of x and n to the given formula. So it will be 720 divided by 6. It is equal to 120. Now, this is the probability histogram of the given distribution of x. It shows that the probability distribution of the population wherein 1/6 represents that each student has different data consumption for their synchronous online classes per day. Let's continue answering the first question. We have to solve for the population variance. This table will help us to easily solve the population variance. The first column represents the students. For the second column represents the data consumptions of the students. The third column, we are going to find the difference of x and the population mean. You have to remember that the computed mean is equal to 120. Next, we are going to find the squared of the results of the third column. Let's solve the first row. So x minus mean is equal to 80 minus 120. It is equal to negative 40. Now, square the result. So negative 40 squared, it is equal to 1,600. Then, do the same process to solve the remaining rows. After that, we are going to find the summation of the quantity of x minus mean squared. As you can see, since we squared each of the resulting observations, it means that the variance will be positive. So now, the summation of the fourth column is equal to 6,850. Now, we are going to use the formula of variance. It is the sum of the square differences between each data point and the mean divided by the number of data values. So we'll have 6,850 over 6. It is equal to population variance is 1,141.67. To solve for the standard deviation, we will just simply square root the given value of the variance. So it is equal to 33.79. So which means that the answer for letter A is that the population mean is equal to 120, population variance is 1,141.67, and the population standard deviation is 33.79. For letter B, we are going to generate the sampling distribution of the sample means given that the sample size is 2, which can be drawn without replacement from the given population. So which means that we are going to use the counting rules for combination. Now we are going to use substitution. Next is we are going to simplify the denominator. Next is we are going to apply factorial notation. So in the numerator, we have 6 factorial. It will be now 6 times 5 times 4 times 3 times 2 times 1. And in the denominator, we have 4 factorial. It will be 4 times 3 times 2 times 1. And for 2 factorial, it will be 2 times 1. Next, we are going to simplify the numerator. We have 720 over, in the denominator, it will be 48. It is equal to 15. So which means that there are 15 possible sample size of 2. Now this is the 15 possible sample size of 2 with the following sample means. So to solve for the first row, we are going to use the formula of sample mean, which is we are going to find the summation of x over the given value of the sample size, which is equal to 2. Now, for the first row, we have 80 plus 150 over 2. So it is equal to 230 over 2 is equal to 115. So this is the sample mean of the first row. Now, let's do the same process to solve the remaining rows. Now we are going to find the summation of the sample mean to easily solve the mean of the distribution of the sample means. So adding all this fourth column will give us 1,800. Now to answer letter C, we are going to do the same process of what we did for letter A. We are going to solve for the mean of the distribution of the sample mean. Now we are going to use the formula for the sample mean, which is the summation of the sample mean over the computed value of the sampling distribution of the sample means for a sample size 2, which is equal to 15. Now we are going to use substitution. It will be 1,800 over 15. It is equal to 120. So it means that the value of the mean of the distribution of the sample means is equal to 120. Now this probability histogram of the distribution of the sample mean shows that among 15 samples, only 137.50 was repeated twice, which represents as 2 over 15. To solve for the variance of the sampling distribution. Using the table for the 15 possible sample size of 2 with the following sample means, we will use this to solve for the variance of the sampling distribution. So on the fifth row, sample mean minus the mean of the distribution of the sample means. Remember that the computed mean of the distribution of the sample means is equal to 120. Now, for the sixth row, we are just going to square the results of the fifth row. Let's try solving the first row. So 115 minus 120, it is equal to negative 5. And negative 5 squared is equal to 25. Now let's do the same process to solve the remaining rows. Then find the summation of the sixth row. So we'll have 6,850. This will help us know what's the variance of the sampling distribution. Now using the formula of the variance of the sampling distribution, Remember that the computed possible sample size of 2 is equal to 15. So in the numerator, we have 6,850, and in the denominator, we have 15. So simplifying this, we'll have 456.67, so which means that the variance of the sampling distribution is 456.67. Now we are going to solve for the standard deviation of the sampling distribution. So we are just going to simply find the square root of the computed value of the variance of the sampling distribution, which is 456.67. So it will be square root of 456.67, it is equal to 21.37. Therefore, the answer for letter C is the population mean is 120, the variance of the sampling distribution is 456.67, and the standard deviation of the following distribution is 21.37. So to answer letter D, what observation can be made with respect to the population and sampling distribution? The computed sample mean and the computed mean of the population are equal. And the sample means and the population vary from different values. As you can see, the probability histogram of the sample means vary from 85 to 162.5, whereas the probability histogram of the population mean varies from 1 to 6. Lastly, the graph, which represents the distribution of the population and sample means, shows that the shape of the graph change from
We proceed to the
population
standard
to the
error of the
sample.
sampling distribution of the sample mean, particularly its general properties. For information, we have three properties. First, the mean value of the sample mean is equal to the population mean. Second, the formula for the standard deviation of an infinite population or sampling with replacement is, so see for yourself. And lastly, the formula for the standard deviation of a finite population or sampling without replacement is this one. This is the finite correction factor. So this quantity is close to 1 if the population is large and the sample size is relatively small. Take note or remember this. The standard error of the sampling distribution of the sample mean is also considered the standard deviation of the sampling distribution of the sample mean. Take a look of its formula. Now, examples. A random sample of size 50 is taken from a large population with mean is equal to 160 and standard deviation is equal to 18. Now, the question is, what is the mean of the sampling distribution of the sample mean? And then the other one, what is the standard error of the sampling distribution of the sample mean? For letter B, by the use of the formula of standard error, all we have to do is to replace the standard deviation and the sample mean in the formula with the given values. The standard deviation is equal 18 with the sample mean of 50. So we change the standard deviation with 18 at the numerator, then we will also change the n or the sample mean with 50. So it will be 18 over the square root of 50. Now, let's simplify. It is equal to 2.5456. Therefore, the standard error is 2.5456. How about when we encounter infinite or unknown population? For example, an infinite population with n is equal to 25, what will be the standard deviation? So, all we have to do is we use the formula of the standard error. We just have to change the n with 25. So, it will be the standard deviation over the square root of 25. Now, we simplify and it will become 5. Therefore, the standard deviation of the sample mean distribution is 1/5 of the population standard deviation.